In this lecture, we are going to discuss about application of Gauss law. We had already discussed two types of application of Gauss law. Now we are going to discuss next type of application of Gauss law. You can see on the board, electric field intensity due to a uniformly charged spherical shell. It means if you have a spherical shell and that spherical shell, it means complete surface. If we are taking like this one spherical shell, so on this surface here, equally charge distributed. Yes or no? We need to find electric field intensity. They will say electric field intensity, either they will say electric field. So both are similar. There is no difference. Yes or no? But we can see here, what we can see, we have three conditions to finding electric field. First, outside the surface. It means this is the surface of a spherical shell. You need to find electric field outside the surface. It means you are going to be consider one point P here, for example, and now you are going to find electric field at this point. It means outside the surface, outside the surface. So for this one, what you are going to be do, you are going to be consider one Gaussian surface. Is it okay or not? Like this, that having radius small r. This is spherical shell, there is a radius capital R. So first we will find electric field outside the surface. Then we will find electric field on the surface of the shell. Yes or no? After that we will discuss electric field inside the shell, like this, here inside the cell, inside the spherical shell. We have three conditions to finding electric field. Is it okay? So now you can see first electric field outside the surface. Electric field outside the surface, it means here. Is it okay now? For this one we need to consider what we can consider one spherical Gaussian surface. So now if we are going to be consider spherical Gaussian surface, so here to here there is a distance small r. So first we need to find electric field at this point, and electric field and this one element area, it means small elementary area, you can say, either small area also you can say. So we can consider one small here area dA. So angle between E and dA you can consider here 0 degree. Yes or no? If you are going to be consider 0 degree here, it means now you need to find electric flux through this surface area. This is small element area is there na. So how much electric field line are going to be passed through this small cross sectional area? So that is known as electric flux. So we are going to be discuss electric flux through this small area. So what we can write here, you can see here. So electric flux, we can write here electric flux through the small area element dA. Yes or no? Small area element dA. So now what you can write, d phi E is equal to E dot dA. Is it okay or not? E dot dA. We need to consider, either we can say we need to find complete electric flux. If suppose that we are going to be consider electric flux through this complete spherical shell. So now you can write here, for complete spherical shell, So for complete spherical shell, if you are going to find electric flux, so you can do what you can do, integration. So now you can do here integration close integration. Okay na, this symbol is showing that close boundary. Okay, so now d phi, okay, E is equal to, so close integral of E dot dA. Yes or no? So we know very well E dot dA means we can write here E dA cos theta. So you know theta here will be 0 degree. Theta will be 0 degree. So now you can write close integral of EA cos 0 degree. Cos 0 1, so we can leave. So now we can write here close integral of EA. So this is a, we can write phi E. What we can write? Phi E like this. Electric flux through the complete spherical shell. We can write like this. So after this one, what we can do here, phi E is equal to E and close integral of the complete spherical shell. It means area of this spherical shell. Area of this spherical shell, if you are going to be right, so we can write here phi E is equal to, what we can write, E into 4 pi, this one is a small r, so r square. Is it okay or not? So we can write here, this one is the equation first. Equation first we can consider. This is a phi E. So we are discussing here application of Gauss law. So we can apply here according to the Gauss law. So what we can apply here, according to Gauss law. According to Gauss law. So we know very well electric flux phi E is equal to Q upon epsilon naught. So we can write here, this is the equation number 2. After this one, we need to compare both equations. This is also electric flux. This is also electric flux. So we need to just compare. So if we are going to be compare, so we can write here E into 4 pi r square is equal to Q upon epsilon naught. So we can write here E is equal to 1 upon 4 pi epsilon naught into Q upon r square. Is it okay or not? Which is required condition. We can say equation number A. Like this we can write. So last time we had discussed, what we discussed? One concept discussed. What concept was there? That concept was sigma. Sigma. What was the sigma? You please try to remember. Surface charge density. Surface charge density, if you are going to be consider, so it was there charge per unit area. Charge per unit area, it means Q upon 4 pi r square. So Q upon 4 pi r square, so you can write here also E is equal to sigma upon epsilon naught Newton per coulomb. Newton per coulomb is a unit of electric field. Is it okay or not? Clear enough? No doubt. Either you can consider this formula, either you can consider this formula. This is a arranging formula. It means after this one you arranged this formula, so you got this one. Till here, any doubt, any problem? You can give the comment also. Either you can join the WhatsApp group. After this one, if suppose that we need to find electric field on this surface here, electric field on the surface of this spherical shell. If you are going to be discussed here, so we need to erase this one. We need to erase this one. So we are going to be erased. Don't be confused. Very simple and halwa concept is there. So first we completed electric field outside the surface. Here we completed. Now we are going to discuss electric field on the surface. Okay, so second we are going to be discuss here. Second, so I am going to write here. Second, electric field on the surface. So on the surface means last time you did, that was the outside the surface. outside this surface means small r was the greater than capital R. This is small r is greater than capital R na. Okay, but here you are going to be consider small r equal to R. So it means here we can write small r equal to capital R. So very simple. As you got this formula, E is equal to 1 upon 4 pi epsilon naught q upon small r square. So finally you can write here what you are going to be do. You are going to be do here. So E is equal to 1 upon 4 pi epsilon naught q upon r square. Why you are going to write this formula q upon r square? Because on surface either for surface also you can write small r is equal to capital R. Okay, any doubt? No doubt, very simple. Okay, after this one you are going to be find what you are going to be find third, electric field inside this spherical shell inside. So you know very well, inside this spherical shell electric field always zero. So electric field zero means, so you can write here inside the surface. So inside the surface electric field always zero. So electric field is zero, it means electric flux also will be zero. No question mark, very simple. If you have any query, any doubt, any problem, so please try to be just give the comment. Okay, and either you can join the WhatsApp group also. So now you understood electric field outside the surface, electric field on the surface, and inside the surface. If you are missing something, so you please give the hint, either give the comment. Thank you so much.